Hi, I'm Holly Mullen. I go to Penn State. I'm going into my sophomore year and I'm majoring in aerospace engineering.
My name is Christina Parsons. I attend Marshall University in Huntington, West Virginia. I'm studying civil engineering and I will be a junior.
My name is Leo Narbonne. I go to University of Massachusetts Amherst. I am in mechanical of engineering and I'm a rising senior.
Hi, my name is Juan Reina. I'm a junior mechanical engineering student at the University of Texas Rio Grande Valley, and I'm expected to graduate 2025.
My name is Matthew Fulton. My school is Cal Poly Humboldt in California. My major is economics, and I'm a rising senior this year.
My name is Trisha Miller. I go to Chatham University, which is in Pittsburgh, PA. I am studying environmental science, and I am going to be a third year.
My name is Sydney Kilgus-Beasley. My major is mechanical engineering. I'm from University of Central Florida, and I am here for the Great Lakes Wind Energy Challenge here at Case Western Reserve University.
Hi, my name is Pruder Benzik. I'm a mechanical engineering major at Rice University in Houston, Texas, and I'm going into my junior year.
My name's Violet Tassini. I'm a rising fourth year at UC Berkeley studying environmental science.
I'm interested in the REU because I'm very interested in wind energy, especially as an aerospace major because they're very connected with fluid dynamics. And now more than ever, sustainability is incredibly important, especially in our energy sector.
I was interested to come to the Great Lakes Wind Energy Program because I'm about 4.5 hours away from Cleveland, so I've been here a couple of times. It's a great city, and I was really excited to be up here for 10 weeks. I'm interested in wind energy because it is a major problem facing my generation. I'm really hoping that in my future career, I'll be on the front lines fighting climate change, and this program has given me the resources and connections to do that.
I knew I was interested in sustainable technologies for a long time. I knew that was going to be my direction. I've always been fascinated by mechanical engineering. I love working with dynamic mechanical systems, or I'm really interested in them. And I think wind energy is a really good combination of dynamic mechanical system and sustainable energies. So this was a great opportunity for me to try something in the research domain and not in the industry.
I'm interested in the Great Lakes Wind Energy Program since I'm from the south of Texas. I've seen the effects of the global warming. That area is it's full of non-renewable energy, and I believe the future of energy is renewable and reliable for society. When I saw the opportunity to apply for the research internship for the Great Lakes Wind Energy Program, I was very excited to see how my engineering skills could be applied to that.
I'm interested in wind energy and the Great Lakes Wind Energy REU because back during the invasion of Ukraine, I started researching on my own time about how sustainable energy systems were not being utilized due to a lot of the energy security in that area. So that prompted me to learn about energy economics and to move on and learn that in graduate school. And the policy side of it is really important. And so the project here with the Great Lakes Wind Energy REU was right up my alley.
By studying environmental science, I've studied a lot of the problems that we're facing for the future and in energy. And by studying more of the engineering aspect, which is what this program does, it's like I'm looking more into some solutions and how we get into cleaner energy and just how to solve the problems that I've been studying. So it's almost looking at all my studies from a new perspective.
I've tried to get as much hands-on experience and research as I can as an undergrad, because the more experience I get, the more capable I'm going to be as an engineer with what I want to do. And what I would like to do is focus on renewable energy and eventually travel to different nations that need help. This program specifically is in the United States. We're on the Great Lakes. There's a very good source of wind here. And so the overriding focus and goal for this was that I would get hands-on experience working with wind turbines.
I'm interested in the Great Lakes Wind Energy REU program because I believe that it would give me a good introduction into what wind energy research looks like and how wind engineers operate. And I'm interested in wind energy because I'm interested in taking part in our future transition to sustainable energy. And as an engineer, I think I can do a lot. And I believe that the GLWind REU program is a great place for me to start, and a great entry point into the field of renewable energy engineering.
So I'm interested in multiple fields that work to improve the state of the environment, sustainable energy being one of them. And although I kind of decided on a career path in wildlife conservation before this, I want to explore something a little different this summer, so I chose wind energy.
So my project got switched, so I got placed in a civil engineering lab that's working with corrosion-free reinforcement alternatives for steel rebar and marine construction. So it's primarily focused on offshore wind turbines. And everything is new to me because I have no involvement with civil engineering at my school, so I learned a lot of lab skills and also structural properties.
My research project is titled Sustainability Metrics for Green Alternatives, which is basically how we measure how green or sustainable something is. So for my project, I studied the existing sustainability metrics and kind of came up with a standardized process to use for research purposes. Case study would be how green a hybrid or a EV charging station is that is powered from wind and solar.
My research project was, we were trying to characterize the wind resource at Cedar Rapids, Iowa, for the turbulent length scale of the wind at that site. Categorizing the data into different directions, so wind coming from certain directions, can look at winds that go over certain types of terrain. If we have like stable air or unstable air because of thermal gradients in the air, that can change what types of turbulence we get.
I worked with the civil engineering department at Case Western Reserve University, and alongside my PI, Dr. Bill, and another cohort member, we looked into how biomimicry, which is a study of how nature's patterns and behavior can be applied to other applications. In this case, we applied it to the engineering of wind turbine blades.
My research project here in Cleveland this summer is the regulatory frameworks for the integration of renewable power systems pertaining to microgrids. And so what we've been researching is the effects of standby rates that are imposed by utility companies on the economic feasibility of microgrid projects that are hopefully being planned on being developed here in Cleveland in the next 4 or 5 years. So my research has been focused on utility regulation, what enables them to levy these charges, and what are the real impacts to the development of microgrids.
We were studying wind turbine blade designs and how to optimize their shapes. So we were looking into designs like seeds, like those helicopter seeds that kind of spin on the way down. We were looking at whale flippers, they have bumps on them. It helps reduce drag and increase lift. So that's all very beneficial when talking about wind energy and efficiency of the turbine blades. We were looking at flexible blades that mimics palm trees. Whenever they blow in the wind, they're forced backwards. So the flexible design kind of mimics that, and it lets a lot more of the wind energy be used for actually creating energy we can use as opposed to in drag forces.
So I was under Dr. Christian Carloni at Case Western Reserve University. What we focused on was concrete and alternative reinforcements as opposed to steel rebar. And that has to do with the wind turbines in the sense that steel corrodes very quickly. And so we needed alternative methods such as glass fiber reinforcements and plastic types of fibers. And so what we studied was the stress and strength properties of concrete embedded with these new alternative materials to replace steel rebar.
My research kind of went all over the place this summer, and that's just the nature of research, as my faculty mentor would often tell me. And so I started in looking at urban wind installations on rooftops and whether or not they were feasible, given like modern technology and zoning restrictions and power, like performance curves and all that. And so I looked specifically at Cleveland I looked at the meteorological data to generate a power estimation for industry-leading wind turbine models. And from that power estimation, I generated like rough payback windows to kind of gauge the economic feasibility of rooftop wind projects.
My research project involves using the footage from thermal cameras near wind turbines that are used to track bat activity. However, our detector still picks up tracks of animals or flying objects that aren't bats, such as bugs. So my specific project works to use machine learning to filter out the bat tracks from those of bugs, since it's not really feasible to separate using deep learning.
I was able to learn a lot from this opportunity because I was placed in a civil engineering lab, whereas my major is in aerospace. So it was a completely different discipline, and I was able to learn a lot of lab skills, there's a lot of hands-on things, and also structural properties.
The main thing I learned from the research experience here was how to do research, so how not to get lost in a literature review and how to get from kind of having an idea on how to solve a problem to actually solving that problem without getting too lost.
So what I've learned from this research experience, I think mostly has to do with the skills I've developed as a researcher. I worked with Pruitt on this project actually, and I think that